So welcome sa ating physics online lectures. So our topic for today is rectilinear motion, or the motion along a straight line. So let's define the following terms. Motion. So motion is defined as a continuous change of position. The word position here means the distance of the point object from reference point or axis. So to illustrate, yan. So in this diagram, so let's say we have an object na yung kanyang initial position is at point P. So this is yung its first position. Then, with respect to the reference point, which is point O, the distance of the initial point is simply x sub 1. Then, let's say this object is moving from point P towards point Q. So, with that, yung point Q natin, yung distance of point Q with respect to the reference point O is x sub 2. Therefore, the change in position, or our delta x, which happens to be the displacement, is now the difference between the final point or the terminal point and the initial point. So that is simply x sub 2 minus x sub 1. And that is our delta x, or the change in position. Then let's define rectilinear motion. So the simplest type of motion is the motion along a straight line. This is called rectilinear motion, or simply linear motion. To describe motion, the following terms are used: displacement, velocity, and acceleration. Okay, so let's define displacement. So the displacement of an object as it moves from one point of its path to another is defined as the vector drawn from the starting point to the final point. So that is always the difference between the final point and the initial point. So as discussed a while ago. So that is our delta x, or simply the displacement. Yan. So that is the difference between the final point, or the x sub 2, minus the initial point, or the x sub 1. So take note that x sub 2 and x sub 1 were measured from a common reference point, which happens to be the point O. So let's say, for example, so consider a jogger moving along the x-axis, where the initial position of the jogger is 10 meters and the final position is 80 meters. What will be its displacement? Okay, so let's provide the solution for this one. So let's say on our x-axis, okay, so for example number 1, so on our x-axis, so let's say we have here our x-axis, and it is said that the jogger, its initial position, let's say this is our reference point, which is the 0 mark, okay, and the initial position of the jogger is at 10 meter. So let's say this is our 10 meter mark. So this is our initial position of the jogger with respect to the reference point, which is the 0. And the final position is at 80. So let's say the jogger moves to the right. Okay, so if you want to the left, you may do so. Okay, so para lang standard, let's try to have the jogger move to the right. So its final position is at 80 meter mark. So 80 meters from point O. So this is the initial position and this is the final position. So basically, the displacement or our delta x is x sub 2 minus x sub 1. So therefore, our displacement or our delta x simply 80 meters minus 10 meters, and our delta x simply 70 meters. So, ganun lang siya. Okay? So, since displacement is a vector quantity as described or as defined a while ago, so it should have both magnitude and the direction. So, you may say that based on our figure, since it moves from left going to right, so you may say that that is 70 meters to the right. Okay? Some may define it as 10 meters to the positive x-axis because oftentimes the direction of going to the right or eastward is considered the positive x, whereas the west, going to west or going to the left, is considered negative direction. So in this case, its magnitude is 70 meters and its displacement is going to the right. Okay? Because again, displacement is a vector quantity. It involves both the magnitude and the direction. Okay? So let's have another one. So for example number 2, if the jogger moves to the left from the initial position of 80 meter to a final position of 20 meter, what will be its displacement? Okay, so for problem number 2. So again, let's place our reference point here. Okay, so its initial position is at 80 meter mark. And it is said that its final position is the 20 meter mark. So here is your x sub 2, which is the 20 meter mark. So take note that the jogger is now moving to the left. Okay? So ganun pa din, let's have delta x, that is always final point minus initial point. Always. Okay? So at all times, that is always the final point minus the initial point. So our displacement is the final point, which is 20 minus 80 meters. So delta x is negative 60 meter. Okay? So the negative sign here denotes that since again we assume to the right positive, therefore we can say that our displacement, because of the negative sign, again, its magnitude is simply 60 meters. Then, the negative sign denotes its direction, which says that it is moving to the left. Okay, so yun lang yung ibig sabihin ng negative sign. Okay, so since technically we do not have negatives in measuring distances or distances. That's why this negative sign here denotes that it moves in the opposite direction. Since we assume to the right is positive, therefore when you arrive with a negative answer, it means that the vector is going in the opposite direction, which is going to the left. Okay, so basically that is the thing about displacement. Okay, so just take note that it is always the final point minus initial point. Let's proceed. So let's have average velocity. So the average velocity of a point object as it moves from point P to point Q is defined as the ratio of the displacement to the time interval. Okay, so simply speaking, when we talk about the velocity or the average velocity, that is simply the ratio of the displacement to the time interval. So that is displacement over time, or the change in position in x over time. Whereas when we talk about the average speed, so the average speed of a point object is defined as the total distance traveled divided by the total time it takes to travel that distance. So when we talk about, again, average velocity, that is simply the displacement or the change in position, or the final point minus the initial point, all over or divided by the time of interval. Whereas the average speed is the total distance traveled divided by the total time it takes to travel that distance. So average velocity is also a vector quantity, whereas average speed is a scalar quantity. So let's say, for example, a runner makes one lap around a 200-meter track in a time of 25 seconds. What were the runner's average speed and average velocity? So let's solve this problem. Okay, so for problem number 3, okay, so a runner makes one lap. When we let's say in the field of racing, so whether it is a marathon or as long as it is a race, when we talk about a lap, we all know that when we say that the runner makes one lap, it denotes that it completes the whole rotation. Okay, so let's say on a circular track, it goes back to its initial position. So let's assume that the uh, track is circular. So let's say on a circular track, okay? So let's say this is the starting point. Okay, so yun yung starting point natin. So when we talk about one lap, that is one complete revolution. Meaning to say, you will accomplish one lap when you go back to the initial position. Okay, or your starting position. So with that, this is your starting position and this is your finishing point. So with that, when the runner completes one lap on this 200, so the circumference of this circle is the 200-meter track. So the time here, or the elapsed time, is 25 seconds. Okay, so when we talk about the average speed, so when we want to find the average speed, that is equal to the total distance divided by the total time. So the total distance, since this is a lap, so that is the full 200-meter track divided by the time. So the time here, the elapsed time to complete that is 25 seconds. Therefore, the average speed is 8 meter per second. So that is your average speed. Then let's have average velocity. When we have average velocity, so again, that is displacement over time. So the displacement, that is delta x. So this is your displacement all over time. So the displacement, that is the final point minus the initial point divided by time. And take note that the final point and the initial point in this case coincide. Okay? So they coincide at the starting point, or the starting point and the final point of this lap is the same. So therefore, there is no difference between the final and the initial point. Kasi parehas lang. Parehas lang yung initial and final point. Because based on the problem, it is stated there that that is one lap. And as I've said, when we talk about one lap, that is the time when you arrive with the initial point or when you go back to the initial point. So with that, the distance between the final point and the initial point or the change in its position becomes 0 because that coincide. So divide lang natin ang time which is 25 seconds. Therefore, its average velocity becomes 0 meter per second. Okay? So 0 because position does not change. So this most of the times velocity and speed are interchanged in its definition. But with this we will have a clear distinction between them. Because when we talk about average velocity, we are talking about the displacement or the change in position. Whereas when we talk about the speed, we are talking about the total distance traveled. So the distance and the displacement sets apart the velocity and speed. Okay, one is a vector quantity and the other is a scalar quantity. Okay, so let's proceed. Now, let's have the instantaneous velocity. So, the instantaneous velocity, so it indicates how fast an object moves at each instant of time and the direction of that motion. Again, because velocity is a vector quantity. So, we use the word velocity to mean instantaneous velocity. Okay, so at that instant. When you say at that instant, at that specific time. Okay, so yun yung sinasabi niya. Acceleration. Whenever the velocity of an object change, we say that the object is accelerating. Okay? So when there is a change of position per unit time or at an instant of time, we have an instantaneous velocity or the velocity itself. Whereas when there is a change in velocity per unit time, we have an acceleration. Average acceleration. So the average acceleration during a time interval t is defined as the change in velocity between the time interval during which that change occur. So that is average acceleration. And the instantaneous acceleration, so defined as the acceleration of a body at a particular time or at a particular instant. So halos kapares ng sa instantaneous velocity. At that specific instant, at that specific time, what is its acceleration? So acceleration without adjective means instantaneous acceleration. Okay? So again, acceleration without adjective means instantaneous acceleration. Therefore, unless otherwise specified or pag walang sinabi, we are to assume that that acceleration is instantaneous acceleration. Else, kung sinabing average acceleration, edi saka. But, if in the problem there is no statement whether it is average or instantaneous or it is a plain acceleration only, we are going to assume that that is instantaneous acceleration. So take note of that. So uniform motion or the motion with a constant velocity. Since the velocity is constant, the value of average velocity is the same as the instantaneous velocity. Okay? Meaning to say, hindi nagbabago yung ating velocity. Kaya nga constant. With that, the average velocity will be equal with the instantaneous velocity. So, magpaparehas lang sila. Kasi nga, the motion is uniform. Or it has a constant velocity. So whenever you see the word uniform motion, it denotes that that is a motion in constant velocity. or the velocity is constant in that particular motion. Then let's have uniformly accelerated motion. So the instantaneous acceleration of at any point in a time interval is equal to the value of the average acceleration over time interval. So uniformly accelerated motion, ibig sabihin, we have a constant acceleration. Okay? So meaning when we have an acceleration, the velocity varies or the velocity changes. Okay? So with that, it differs with uniform motion. Okay? So again, when we have uniform motion, we are talking about a constant velocity. When we are talking about uniformly accelerated motion, this denotes that we have a constant acceleration. When we have constant acceleration, the velocity changes. Okay? But that particular or that specific change in velocity, which is defined as acceleration, is constant. Okay? So, wag malilito. Okay? So, uniform motion and uniformly accelerated motion. Again, uniform motion, constant velocity. Uniformly accelerated motion, constant acceleration. Then, in studying rectilinear motion, it is very important that we know the following kinematic equations. So, these are derived uh, from the definition of the uh, velocity and acceleration. So, the kinematic equations, so we have three kinematic equations or the formulas to be memorized or to be familiarized in the field of rectilinear motion. So, we have V is equal to B sub O plus A times T. So, yung V here is the final velocity. V sub O is the initial velocity. A is our acceleration and T is the time interval. Okay? So, in a uniformly accelerated motion, we have these formulas. Okay? So, V is equal to V sub O plus acceleration times time. Okay? So, another equation, we have V square is equal to V sub O being square plus 2AX. So, where X here is the distance or the displacement or the total distance covered. Then, another formula, X is equal to V sub O times T plus 1 half AT square. So, again, X is our displacement. So, V is the final velocity, V sub O is the initial velocity, A is the acceleration, T is for time, and X is for the displacement or the distance covered. So, let's apply the following formulas and principles in this set of examples. So, for example number 1, okay, a motorcycle moving with an initial velocity of 8 meters per second undergoes a constant acceleration for 3 seconds, at which time his velocity is 17 meters per second. What is the acceleration? How far does he travel during that 3-second interval? Okay, so let's solve this one. So, number 1, okay, a motorcycle moving with an initial velocity. So our V sub O is equal to 8 meter per second. Undergoes a constant acceleration. So acceleration is constant. Therefore, this is a uniformly accelerated motion. for 3 seconds. So, yung elapsed time natin is 3 seconds. At which time his velocity. So, the velocity at that instant is 17 meter per second. So, for letter A, na tanong, what is the acceleration? And for letter B, how far does it travel during that 3-second interval? So, that is simply x. Okay? So, with that, we are just going to apply the formulas na meron tayo. Okay? So, for number 1, so, since the use of the kinematic equation, the technique na we can apply is to simply apply the formula which fits with your given. So, kung alin lang yung formula na kompleto dun sa given mo, yun yung pinakamadaling gamitin. So, in this case, let's say, our formula number 1 or the equation number 1 is v is equal to v sub o plus a times t. So, we have there the final velocity, initial velocity, acceleration, and time. In the second equation, we have the final velocity, initial, acceleration, and the displacement. So, notice in equation 2, we do not have acceleration, we do not have the displacement. So, we have two unknowns in the second equation. Therefore, we cannot use that. In the third equation, again, we have the displacement, initial velocity, time, acceleration. So, again, we do not have acceleration yet and the displacement. So, again, equation 3 has two unknowns, so we cannot apply that. But, equation 1, since we are given with the final velocity, initial velocity, and time, we can find for the acceleration. So, in that way, we can say that the best formula to be used is equation 1. Okay? Else, you will equate equation 2 and 3. Okay? So, mas mahirap. So, with that, try na lang natin si formula number 1. So, we have V is equal to V sub O plus acceleration times time. Okay? So, we have the final velocity, initial velocity, and time, but we do not have acceleration. So, we are going to find acceleration. So, deriving the formula for acceleration, transpose lang natin. So, pag tinranspose natin, we will have V minus V sub O is equal to acceleration times time. So, when we want to find acceleration, that is simply V minus V sub O all over time. Okay? So, let's discuss first the formula that we derive. Okay? So, here we have acceleration is equal to V minus V sub O divided by time. Okay? Or the final velocity minus the initial velocity divided by time. And as you can see in the numerator, the difference between the final velocity and the initial velocity is simply the change in velocity divided by time. Now we have the ratio between the change in velocity and time. And that simply defines acceleration. Okay, so as defined earlier, that is acceleration, the change in velocity per unit time. Okay, so notice in the kinematic equation, we can derive that same formula. So we can say that the kinematic equation is reliable. Okay, so yun. So substituting, so A natin, V, we have the final velocity that is 17 meter per second minus the initial velocity that is 8 meter per second divided by the elapsed time, which is 3. Okay, so we have 17 minus 8, that is 9 meter per second divided by 3. Therefore, our acceleration is 9 divided by 3, so that is 3 meter per second square. So that is your acceleration. Okay? So 3 meter per second square. So meter per second square or displacement divided by the square of time is the unit of acceleration. Okay, so acceleration here is 3 meter per second square. Then let's have letter B. Pinapahanap na padalawa. So in letter B, how far does he travel during that 3-second interval? So hinahanap yung X. So with that, since we are given with the acceleration already, we may use any of the two. So the first formula or the second formula or the third formula. Okay? So let's say, let's try the third formula first because direct na yon. So the third formula, we have x is equal to VOT plus 1 half AT square. So substitute lang natin. X is equal to VO. VO natin is 8 meter per second times T, which is 3, plus 1 half. Acceleration natin is 3 meter per second square. And T being square natin, so that is 3 second being square. So X natin is, okay. So let's try using our calculator. Okay. So this is our calculator. So X natin, that is simply 8 times 3 plus 1 half. So 1 half A, that is 3 times 3 square equals, so that is 75 over 2 or 37.5. So we have 37.5 meters. So that is the unit of our displacement. Okay, or the how far does he travel? So he traveled 37.5 meters. Okay, running at an acceleration of 3 meter per second square for 3 seconds. Okay, so let's say you want to use the second equation. So let's say you want to use the second equation. So that is v square is equal to vo square plus 2ax. So deriving x here. So diretso na natin. X is equal to v square minus vo square divided by 2a. So x is equal to, b square minus vo square divided by 2a. So final, that is 17 square minus initial, that is 8 square divided by 2a, that is 2 times 3. So x natin will be, so let's say yun yung naisip mong formula. So let's try. So that is 17 square minus 8 square divided by 2 times 3. So 2 times 3. So the same. X natin is 37.5 meters. Okay, so any. Okay, so the kinematic equation will satisfy each other. Okay, so kahit alin pwede nating gamitin. Okay, so let's have the second problem. So the velocity of a train is reduced uniformly from 15 meter per 15 meter per second to 7 meter per second. Okay? While traveling a distance of 90 meters. So compute the acceleration And how much farther will the train travel before coming to rest, provided that the acceleration remains constant? Okay, so let's solve this one. So as you can see, it is always helpful na idodrawing muna natin yung ating problem, so that we can analyze it. So let's have number 2. Okay, so the velocity of the train is reduced. So let's have here train. Okay, syempre line lang. Okay, so we have a train. So the velocity of the train reduced uniformly. So ibig sabihin, the initial velocity here is 15 meter per second. And it is reduced uniformly. Meaning to say, it is braking or it is slowing down. With that, we can say that its acceleration is reducing. Its velocity is reducing. Okay? Or sometimes it is called the negative acceleration or simply deceleration. Okay? So the train is simply decelerating or it is slowing down. When it is going faster, it increases in speed, it is called acceleration. Then when it is slowing down, it is called deceleration or the negative acceleration, deceleration. Okay? So going back to the problem, so the initial velocity here is 15 meter per second. Then, at a distance of 90 meters, so yung distance na ito, okay, so yung distance natin dito is 90 meters. So at a distance of 90 meters, it reduced uniformly. So yung final velocity niya at this point is 7 meter per second. Okay? So pinapahanap sa atin is its acceleration. Okay? So yan. Then, for letter B, how much farther will the train travel before coming to rest? So, obviously, since it is still running at 7 meter per second, it is not coming to rest. Because when we want the object to come to rest, the velocity should be 0. Okay? So, ibig sabihin, the train will continue to run for another distance, let's say distance x, okay, so of an unknown distance before it comes to rest. So let's save it as b prime. Therefore, the b prime should be 0 meter per second. So for us to say that the train stops, okay, or the train comes to rest. Okay, so as said in the problem, we have here an acceleration. And that is the same acceleration that will be all throughout. Okay, so again, this is a uniform acceleration. Parehas lang. So, ang pinakaiba lang nila, so initially, it decelerates from 15 to 7. Then, to 0. Okay? So, paano muna natin si acceleration or the negative acceleration or deceleration. So let's prove that the value of acceleration here should be negative because we are saying that that is negative acceleration or deceleration. Okay, since we have the initial velocity, final velocity, distance or displacement, and acceleration, the formula na fit para dito is the formula number 2. So we have v square is equal to vo square plus 2ax. Okay? So, since we want to find the acceleration, so that is v square minus vo square divided by 2x. Okay? So, para yon dito sa point na ito. So, let's have this as x sub 1 para hindi tayo malito. So, acceleration here, the final acceleration for the first phase. So that is 7 meter per second, then being square minus the initial, which is 15 being square, divided by 2 times x. So it ran for 90 meters. So isolve natin to. So let's have our calculator. Okay, solving this. So we have 7 square minus 15 square divided by 2 times 90. Okay, so equals. So yung acceleration natin, and as you can see, that is negative. So I will use the fraction para ma-avoid ko yung discrepancy ng decimal places. Okay? So I will use negative 44. So yung acceleration natin, as you can see, is negative. So that is negative 44 over 45 or 0.9777 meter per second. So notice that is negative, meaning to say that our train is decelerating or it exhibits or it experiences negative acceleration. It slows down. So store lang natin to sa A. Okay? So store natin to kay storage location A. Then, ito yung anong pinapahanap. So, for B, we are tasked to find how much further will the train travel before coming to rest. So, before coming to rest, the train again will continue to decelerate at a rate of negative 44 over 45 meter per second square. It will continue to slow down. So, with that, the final velocity at this point will be the 0 meter per second. Okay? So, let's say you want to consider 15 meter per second as the initial velocity and the 0 meter per second as the final velocity. Okay? So, this is your V sub O, this is your final velocity. So, again, we'll be using the formula number 2. So, we have V square. So, we have V square. In this case, that is V prime is equal to VO square plus 2AX. Okay? So, in this case, V natin is, let's derive first the value for X. So, notice, X here should be the total distance from VO going to V prime. Okay? So, let's illustrate. So, let's say that is the distance from VO going to V prime. Okay? So, this is the total distance from the initial velocity going to the final velocity. So, let's save it as x prime. Okay? So, therefore, we can modify this one, that is b prime being square is equal to bo being square plus 2a multiplied by x prime. And we are going to find the value of x prime here. So, x prime is equal to VO square minus V prime square divided by 2A. Okay? So, X prime here is equal to, so VO square, so that is 7. So, that is 7. Sorry, this should be B prime square minus VO square. So, same formula with this one. So, X prime rather should be B prime square minus VO square divided by 2A. So, B prime square, we have it as 0 being square minus 7. Sorry, that should be 15, the initial. So, that is 15 square divided by 2a. So, a here, we are going to include the negative. So, negative, kasama yung sign, 44 over 45. So, our x prime here is, so 0 square minus 15 square, so 0 square minus 15 square divided by 2a. So, this is our acceleration. So, 0 square minus 15 square divided by 2 times negative 44 over 45. Or you may use the storage location A kasi doon naman siya nakalagay. Equals, so this is our total distance, 115.0568. Okay, so I will use this value. Okay, so I have 115.0561. So I will use the 4 decimal places only. 0561 meters. So that is your x prime. Okay? 0568 pala. Okay, so that should be 115.0568 meters. But going back at the problem, it is asked how much farther. Okay, so how much farther, ibig sabihin, from the 90 meter mark. So we are not finding x prime, but we are finding x sub 1. So as you can see, x sub 1 is the difference between x prime and 90. So that is simply x prime minus 90 meters. So x1 natin is equal to, so 115 buo 0.0568 minus 90. Okay? So x sub 1 natin is, pag ginawa natin yan, so this, yung answer na ito, minus 90. So that is our x sub 1. So we have 25. So x sub 1 natin is 25.0568 meters. So yan yung hinahanap. How much farther? Meaning to say, after reaching the 90 meter mark, the train will continue to run for another 25.0568 meters before coming to rest. Or all in all, the train will travel 115.0568 meters. Okay? So let's have another solution. So for the second solution, let's put it here. So for the second solution in finding the value of x sub 1, okay, so you can cut down the figure. So instead of referring to the initial velocity, you may refer to this point because x sub 1 is from the 90 meter mark going to the final mark. So you may cover up this one. So the final velocity 1 in the first condition, which is 7 meter per second, you may use it. Okay, so you may use this one as the initial velocity prime. Okay, so the initial velocity for the second condition. Okay, so let's do that. So let's refer to this point sa 90 meter mark. So para diretso ng x sub 1 yung ating makukuha. So with that, again, we are given with velocities and acceleration. So we can find x. So from that, x sub 1 is equal to final velocity, that is b prime being square, minus the initial velocity, that is bo prime being square, divided by 2a. So x sub 1 is equal to b1 prime, so that is 0 being square, minus bo prime, so that is 7 being square, divided by 2a. So 2 times negative 44 over 45. So yung x sub 1 natin is, tingnan natin. Okay, so we have b prime 0 minus bo, which is 7, divided by 2 times, so kasama yung negative sign, negative 44 over 45 equals. And we arrive with the same answer. So, diretso na. Mas mabilis. Okay, so that is 25.0568 meters. So, we just refer to the 90-meter mark. So, doon na lang tayo kumuha sa 90-meter mark. Oops, sorry, putol pala. So, when we solve this, substituting, putol pala, sorry. Okay, so yun. Okay, so we will arrive with the same answer. Okay, so I just substitute these values. Okay, so yung values natin kanina. Okay. Okay, so knowledge on reference points is important, okay, in this topic. Okay, let's proceed. Third problem. So a train starts from rest at a station and accelerates. So it moves faster or it increases in speed. So, and it accelerates at a rate of 2 meters per second for 10 seconds. It then runs at a constant speed for 30 seconds, then decelerates at 40 meters per second until it stops at the next station. Find the total distance covered. Again, let's try to draw the figure of the problem. So for problem number 3, okay? So a train starts from rest. So the initial velocity here, so let's say that is V sub O, that is equal to, so since it starts from rest, so that is simply 0 meter per second. Okay? And accelerates at a rate of 2 meter per second for 10 seconds. So it accelerates, so its acceleration is 2 meter per second for 10 seconds. So for 10 seconds, yeah, it accelerates or it increases in speed, okay, at a rate of 2 meter per second. So therefore, meron dito final velocity. So let's have it as v sub 1. Okay, so we do not know the value of v sub 1, but we have this given value, so we can solve for v sub 1. Okay, so let's say this is our first distance covered, okay, which is unknown. Then, it then runs at a constant speed for 30 seconds. So it runs at a constant speed. So for the second leg, it runs at a constant speed of 30 seconds. Since it runs at a constant speed of 30 seconds, the acceleration, since it is running at a constant speed, the acceleration is 0. Okay? So, constant daw yung ating speed. Therefore, the velocity here is the same as v sub 1. So, the velocity here will be the same. Parehas lang. Then, it decelerates at 4 meter per second. So, until it stops. So, the final velocity here, so let's have here v sub 2. So, for the third leg, x sub 3. So the final velocity v sub 3 is what? 0 meter per second. Why? Because as stated in the problem, it stops. So but before it stops, it decelerates. So it slows down at a rate of 4 meter per second. So that should be negative because it is slowing down. 4 meter per second square. Okay? So ayan yung ating diagram. So find the total distance covered. So that is simply the sum of x sub 1, x sub 2, and x sub 3. Okay? So obviously, you cannot use from 0 to 0. Okay? Because wala tayong masosolve. No. So we are going to solve this one partially. Okay? So let's consider the first leg. So let's find x sub 1. Since we have acceleration, we have time, we have velocity, the initial velocity, so we can find the acceleration there. We can find the final velocity using equation 1. Okay? So because as you can see, we need the value of v1. So isolve muna natin si v1. So using the formula v, or the final, is equal to v sub o plus acceleration times time. So in this case, so that is v1. So we have v1 is equal to vo plus ap. Okay, so v1 is equal to vo. So vo natin is 0 plus acceleration natin is 2 meter per second square times 10. Therefore, v sub 1 natin is simply 20 meter per second. So that is our first velocity. Okay? Gamitin natin yan mamaya. Then, using equation number 3, or you may use equation number 2, okay, but I will use equation number 3 because based on the given, I have the initial velocity, I have the time, I have the acceleration. Okay? So, just in case lang na mali, yung kuha ko ng V1, at least may itama ko si x sub 1. Because I look at the given. So, when I want to find x sub 1, that is VO times t, and plus 1/2 acceleration times time being square. So, substituting x sub 1 is equal to VO, that is 0, times time, which is 10, plus 1/2, times acceleration is 2, and time natin is 10 being square. So therefore, x sub 1 natin is, so this will be cancelled out. Cancel na to. 110 squared, that is simply 100. So yung x sub 1 natin is 100 meters. Okay? So for the second leg, so it runs at a constant velocity. Therefore, the acceleration is 0. And the initial and the final velocity are the same. So that is simply both 20 meter per second. Okay? So we have the initial velocity. Okay? So we have the initial velocity. The acceleration is 0. So we can find using the third equation, that is x is equal to VOT plus 1/2 AT squared. So that is x sub 2 is equal to initial velocity that happens to be equal with the final velocity. So we have v1 times t natin. So let's have it as t sub 2. So let's call 30 seconds as t sub 2 plus 1/2 a times t square. So t sub 2 being square. So substituting x sub 2, v1 natin is, so v1 natin is 20. Then, time natin is 30. Diba? So, 20 times 30. Then plus 1/2. Take note that the acceleration is 0. So, yung time natin is 30 being square. So, this will be cancelled out. So, x sub 2 natin, that is simply 30 times 20. So, that is 600. So, we have 600 meters here for our x sub 2. Okay, so that is 30 times 20. Then, for the third leg, okay, so for the third leg, so to find x sub 3, so we have v sub 3 is 0 meter per second. So it decelerates at a constant rate. So we may use, since we do not have time here, so we'll be using equation number 2. So that is v squared is equal to vo squared plus 2ax. So from here, we can find x sub 3. So x sub 3 is equal to v3 square minus the initial, I will use v sub 2. So that is v sub 2 square divided by 2a. So I used v sub 2 here, not v sub 0, because x sub 3 is from v sub 2 going to v sub 3. So in this case, the initial position is at v sub 2. So, ganun siya ka-importante. Okay? So, x sub 3 is equal to v sub 3 minus v sub 2 divided by 2a. So, substituting, x sub 3 is v sub 3, that is 0 square, minus v sub 2. V sub 2 is equal to v sub 1, that is 20, being square, divided by 2 times negative 4. Okay? So, x sub 3 is equal to, so that is 400 divided by 8. Okay, so we have 400, so negative 20 being squared, that is negative 400 divided by negative 8, so we have 50 meters here. Okay, so since we are finding the total distance, so x total natin is the sum of x sub 1, x sub 2, and x sub 3. So x total will be 100 plus 600 plus 50. Plus, so x total natin is equal to 750 meters. That is your x total, 750. Okay, so let's continue. So for the fourth problem, okay, a motorist traveling with a constant speed of 15 meter per second passes a school crossing corner where the speed limit is just 10 meter per second. So overspeeding. Okay, overspeeding si motorist. Just as the motorist passes the school crossing sign, a police officer on a motorcycle stopped there. So may nakabantay, starts in pursuit with a constant acceleration of 30 meter per second square. Okay? So, that should be 30 meter per second square. So, yung 2 is an exponent. Okay? So, how much time elapses before the officer passes the motorist? So, when in physics, when we talk about passes, so it does not mean overtake. Okay? Or sometimes the word overtake here denotes that the officer and the motorist are at the same distance. Okay, so yun yung overtake, hindi yung typical na overtake natin na nauna na yung isa. Okay, so in this case, when we talk about passes or overtake, it means that they are at the same position. Okay, so since the motorist is running at a constant speed, whereas the police officer is running at a constant acceleration, or he is accelerating, so he is increasing his in speed at a constant rate. Therefore, at that specific time, the officer is about to overtake. So yun yung ibig sabihin nung the officer passes the motorist. He is at the same distance with the motorist. And letter B, what is the officer's speed at that time? And at that time, what distance has each vehicle traveled? Okay, so let's solve this. So again, let's draw the figure. So for problem number 4. So let's say first for the motorist. Okay, so for the motorist, so let's say ito yung path that the motorist travel. Okay, so let's say the reference point here is the school crossing corner. Okay, so the motorist, so the initial velocity of the motorist as stated is 15 meter per second. And since he is running at a constant speed, so its final velocity when they meet is the same 15 meter per second. Acceleration here is 0 for the motorist. Okay? Then, let's have for the police officer. So, the police officer, dito na lang siya sa baba. So, the police officer. For the police officer, so this is the path of the police officer. Okay? So, they first meet at the school crossing corner. Okay? So, since the police officer's vehicle or his his vehicle or his motorcycle is initially at rest, the initial velocity of the police officer is 0. Okay? And we do not know his final velocity. Okay? Then, it is said that the officer is accelerating at 3 meter per second square. Okay? So, obviously, so as I've said, they are running, they traveled the same distance with respect to the school crossing corner. Okay? So, therefore, kung aabutan ni officer si motorist, therefore, their distance x will be the same as well as the elapsed time. Okay? So, the time traveled by the motorist and the police officer from the school crossing corner up to the point where they meet will be the same. Okay? And same thing with their distances. The distance that they covered. Okay? So, from this argument, we can say that the distance x traveled by the police is equal to the distance traveled by the motorist. And the time traveled by the police is the same time traveled by the motorist. So we are going to use the following argument. Okay, since we have acceleration, we have initial velocity for the police. Okay, so we do not have the time, we do not have the final velocity, okay, when they met. Okay, so let's consider first the motorist. Okay, so for the motorist, okay, so for the motorist, we have a zero acceleration, we have the constant velocity. Okay, so we can find x. Okay, so using so we cannot use the first equation because sa first equation the initial and the final velocity are the same, so when we subtract them we will have 0. Okay, because as I've said, the acceleration there is 0. So let's use so we cannot use also the second condition because again the acceleration there is 0, so wala tayong masosolve. So let's have the third equation. So let's have x is equal to VOT plus 1/2 80 square. So in this case, that is x of the motorist is equal to initial velocity of the motorist times time of the motorist plus 1/2 acceleration of the motorist times time of the motorist being squared. Since let's substitute first. So x of the motorist, the initial velocity is 15 meter per second, and we do not have the time of the motorist. Then that is plus 1/2. His acceleration is 0. So this is the time of the motorist being square. So we can cancel this one out. Therefore, let's have x of the motorist is 15 times time of the motorist. So let's have this as equation 1. Okay? Then, let's consider the police officer. So for the officer, for the police officer, okay, so let's use the same formula. Equation x is equal to VOT plus 1/2 AT squared. So for the police, that is x sub p is equal to initial velocity of the police, time of the police, plus 1/2 multiplied by acceleration of the police times time of the police being square. Okay, so substituting, so we have x of the police is equal to initial velocity of the police is 0 times time of the police plus 1/2 acceleration of the police. Okay, so the acceleration of the police as stated is 3 meter per second square. Then let's have here the time of the police being squared. So we can cancel this one. Therefore, the x of the police officer is equal to 3/2 or 1.5. So that is 1.5 times time of the police being squared. Okay, so let's have this as equation 2. Okay, but we said a while ago that x of the police is equal to the x of the motorist, and the time of the police is equal to the time of the motorist. So with that, we can equate. So let's equate equation 1 and equation 2 because x of the motorist is equal to x of the police officer. Okay, so substituting, that is 15 multiplied by, so x of the motorist is 15 multiplied by the time of the motorist. That is equal to 1.5 times time of the police being square. But we all know the time of the motorist is equal to the time of the police. So substituting, that is 15 times time of the police is equal to 1.5 times time of the police officer being square. So we can cancel out this one, and we have 1.5 times time of the police is equal to 15. Okay, so we can find the time of the police, and that is simply 15 divided by 1.5. Therefore, the time of the police we have here is equal to, okay, so yung time of the police natin is 15 divided by 1.5, so that is simply 10 seconds. And that is the same as the time of the motorist. So that is for letter A. Okay, so the time elapses before the officer passes the motorist is 10 seconds. So within 10 seconds, Okay, so within 10 seconds, the police will pass or will meet the motorist. Okay, in 10-second time. Okay, so for letter B, what is the speed of the officer at that time, and at that time what distance has each vehicle traveled? Okay, so obviously the distance traveled by both the motorist and the uh, police will be the same. So I will solve first letter C, which is the x of the motorist. So that is 15 times time of the motorist. So that is 15 times 10, so that is 150 meters. Okay, for the police, x sub p, so that is 1.5 times time of the police being square. So time of the police is 10 seconds, being square is 100 times 1.5. So that is 150 meter also. So obviously, the value of their distances will be the same, both in 150. Okay? Then for letter B, bitan ko lang si letter B. So, what is the officer's speed? So, we are finding the speed of the police at that time. So, that is simply at t is equal to 10 seconds and x sub p is equal to 150 meters. So, we'll be using these values. So, we may use uh, the first formula, since we are given with acceleration and time and velocity, or we can use the second one. Okay, so let's say using the first formula, v is equal to vo plus at. Okay, so when we use this one, so the velocity is equal to 0 plus 3 times time of the police. The time of the police is 10. So his velocity, okay, his velocity is 30 meter per second. That is the velocity of the police. Okay? Or you may use the second one. So that is v square. So or natin dito. Or let's use v square is equal to vo square plus 2ax. So 2ax. So v square natin is equal to vo square. So vo square natin is 0 square plus 2. A natin is 3. X natin is 150. Okay? So v is equal to square root of this one. So okay. So if you want to find the value of b here, so that is the square root of 2 times 3 times 150. Okay, and that is the same. So because this is 2 times 3 is 6 times 150, that is 900. Okay, and square root of 900 is 30. So that is the same 30 meter per second. Okay, so parehas lang. Any of the two you can be used. Okay. Okay, so let's proceed to the next problem. Two buses start at the same time towards each other from terminals A and B 8 kilometers apart. The time needed for the first bus to travel from A to B is 8 minutes, and that of the second bus from B to A is 10 minutes. So, how much is the time needed by each bus to meet each other if they traveled at their respective uniform speed? Okay, so this is a uniform motion, meaning to say the buses are not accelerating. Okay, So let's have problem number 5. Okay. Okay. So let's draw the figure. So let's say bus A. So bus 1. Okay. For the first bus, so traveling from A to B. So let's say this is our points. Okay. So here is your point A. Here is your point B. So let's say bus 1 will go to the right. Okay. Or from point A to B. Okay. So as stated, bus 1, so since points A to B, yung distance between A and B is 8 kilometers. Then, for bus 1 to travel from A to B, he needs 8 minutes. Okay? So, to travel from A to B, he needs 8 minutes. So, let's call this as the distance covered by bus 1, then this is the time covered by bus 1 to travel from A to B. Noting that the velocity of bus 1 and the final velocity of it is the same. Okay, so final velocity is the same. So acceleration natin here is simply 0. Okay, then from bus B going to A, so from B going to A naman tayo. So in this direction. Okay? Okay? So the distance of bus number 2 is the same. So that is 8 kilometers, but the time is 10 minutes. Okay? So this is the initial point of bus B. So this is the initial point, then this is the final point, which is the initial velocity and the final velocity of bus number 2, but that is the same because as stated, it runs at a constant speed, so acceleration again here will be 0. Okay? Now, we are asked at how much time is needed by each bus to meet each other if they traveled at their respective uniform speeds. Okay, so let's say they meet at this point. Okay, so we do not know if, okay, to make it more realistic, since we can say that bus 1 is faster than bus number 2 because it only took 8 minutes for it to travel from point A to B, whereas the bus B traveled from point B to A. The second bus traveled from point B to A for 10 minutes. So bus 1 is faster. So to make it more realistic, syempre mas malaki yung mako-cover ni bus 1. Okay, so let's say they met at this point. Okay, so therefore, this will be the distance covered by bus 1. Okay, whereas this part will be covered by bus number 2. Okay, so with that, here we do not know the elapsed time of bus number 1, and we do not know the elapsed time of bus number 2. Okay, so with that, let's draw some conclusions here. Okay, so let's draw some conclusions based on our figure. So we can say that the sum of the distance covered by bus 1 and the distance covered by bus 2 will be the total distance of 8 kilometers. So let's have this one as our equation 1. Then we can also say that the time covered by bus number 1 and the time covered by bus number 2 for them to meet should be equal. Okay? So let's have this as equation 2. Okay? Then we know that the velocity of bus number 1, so that is the same. So velocity is displacement over time, but let's derive them from the kinematic equation. So let's say V. So let's say V sub 1 is equal to VO1 plus AT using the initial condition. No, cannot use equation 1 because acceleration here is 0. So we cannot use this. So instead, let's use the third equation. So from the third equation, x is equal to VO times t plus 1 half AT squared. Since acceleration is 0, so we will have x is equal to VO times t, or the velocity is simply distance over time. Okay? So let's use this equation. X is equal to VOT. So let's have x sub 1. So therefore, x sub 1 is equal to initial velocity of 1 multiplied by time of 1. So x sub 1. So we need to find the initial velocity 1. Okay? Since we have the distance covered, which is 8 kilometers, and the time covered, which is 8 minutes, and the acceleration is 0. Okay? So we have the distance, the velocity, the time. So from here, so let's say at bus 1. So at bus 1, then let's have it as from point A to B. So let's find first the velocity of bus 1. So bus 1 natin from A to B. So its x sub 1 is its x is equal to from A to B is 8 kilometers. Then its time is equal to 8 minutes. Therefore, from A to B, so using the equation, again, x is equal to VOT plus 1 half AT squared. Acceleration is 0. X is equal to VO times t. X is equal to VO times t. So VO times t. So in this case, x is equal to, so XAB natin. So V going to AB. So B1 times t. So therefore, the initial velocity of bus 1 is equal to x over t. So that is 8 kilometers per 8 minutes. Okay? So that is our velocity. 8 kilometers per 8 minutes. Therefore, the initial velocity is 1 kilometer per minute. So that is our velocity ng bus 1. So let's consider bus number 2. So at bus number 2, so from B to A, so let's use the same formula. Velocity is equal to x over time. Therefore, the velocity, so the initial velocity of bus number 2, or its velocity kasi constant naman, is its x, which is 8 kilometers per 10 minutes. So that is 0.8 kilometer per minute. That is the velocity of bus number 2. Okay? So that is 0.8 kilometers per minute. So we'll be using this values. So from since we have x sub 1 plus x sub 2 is equal to 8 kilometers, t sub 1 is equal to t sub 2. And we know that the velocity of bus 1 will always be equal to its initial velocity. Why? Because we have constant velocity. Therefore, we will have this as 1 kilometer per minute. And from this equation, so V1 will be equal to x sub 1 all over t sub 1. Okay? So, therefore, x sub 1 is equal to v sub 1 times t sub 1. So, substituting x sub 1, so v sub 1 natin is v sub 1, so that is 1 kilometer per second times kilometer per minute times t sub 1. So let's have x sub 1 is equal to t sub 1. So let's have this as equation 3. Okay? So we derive that x sub 1 is equal to t sub 1. Okay? Then, so we considered here bus 1. And let's consider bus number 2. So v sub 2 is equal to the initial velocity of bus 2 because they are running at a constant speed. So that is 0.8 kilometer per minute. Okay? So that is v sub 2 is equal to x sub 2 over t sub 2. So when we cross multiply, x sub 2 is equal to v sub 2 times t sub 2. So when we substitute, x sub 2 is equal to, so x sub 2 is v sub 2, that is 0.8 kilometer per minute times t sub 2. So let's have here t sub 2. Okay? Now let's have it as equation 4. Okay? But we know that t sub 1 is equal to t sub 2. And based on equation 3, that is equal to x sub 1. Okay? So t sub 1 is equal to t sub 2. And t sub 1 is equal to x sub 1. So this is simply the combination of equations 2 and 3. So t sub 1 is equal to t sub 2 is equal to x sub 1. So substituting, we can say that x sub 2 is equal to 0.8 of x sub 1. Okay, we just substitute the values. Okay, so let's have this as equation 5. Then let's substitute equation 5 to equation 1. Okay, nalagay ko na lang dito. So let's substitute. Okay, substitute natin equation. So let's substitute equation 5 to equation 1. So that is x sub 1 plus x sub 2. So x sub 1 plus, so palitan natin, x sub 2 is equal to 8 kilometers. Then we said that x sub 2 is equal to 0.8 of x sub 1. So that is equal to 8 kilometers. Lagay ko na lang dito. So we have 1. So x sub 1 plus 0.8 x sub 1. So that is 1.8. X sub 1 is equal to 8 kilometers. So from here, we can solve for x sub 1. That is 8 kilometers divided by 1.8. Therefore, that is 8 divided by 1.8. Result lang natin sa ating calculator. So we have it as 8 divided by 1.8 was, so that is 40 over 9 or 4.444. Okay. So that is 4.4444 kilometers. So that is the distance covered by bus 1. Okay? So if you want to find the distance covered by bus number 2, so x sub 2 is equal to 0.8 of x sub 1. So multiply lang natin. So 0.8 of 4.4444. So x sub 2 is simply, so multiply lang natin ito ng 0.8. That is 32 over 9 or 3.5556. That is 3.5556 na lang para magparehas ito. Kilometers. Or you may subtract 4.444 from it and you will surely arrive with this value of 3.5556. Okay? Parehas lang yan. So, diba ito ay 32.9. So, let's check. 32 over 9 plus yung isa ay ano ba itong isa? Okay, so again, let's present. That is bus number 1 traveled at 40 over 9. Okay, and bus number 2 traveled at a distance of 32 over 9. So equal, so as you can see, that is at 8 kilometer mark. Okay, so yan. So as you can see, it is logical to say that since bus number 1 is faster than bus number 2 at the same instant or at the same time, at the same span of time, bus number 1 will logically cover a longer distance compared to bus number 2 kasi mas mabilis siya. So, based on the result of our solution, bus number 1 traveled for 4.4444 kilometers, where bus number 1 rather covered 4.444 kilometers, whereas bus number 2 traveled 3.5556. Why? Because again, bus number 1 is faster than bus number 2. So, at the same span of time, it will cover longer distance. Okay, so that's it for our lecture about rectilinear motion. So in this topic, again, it is important that you know the principles and the definitions of velocity, the terminologies used like uniformly accelerated motion, constant motion, uniform motion, constant velocity, etc. So it is important so that you can analyze if the acceleration is constant, if the acceleration is zero, if the velocity is changing, or if the velocity is constant, or if the velocity is zero. Okay, so those terminologies are very important. And also, these kinematic equations. So these three are very important. And again, as I've said, the use of these depends on your given. So you will use whichever fits with the given that you have in the problem, as well as of the unknown. So kung ano yung hinahanap. So it depends on the statement of the problem. The use of these three kinematic equation, and rest assured, each of them will satisfy one another. Okay, hindi magka-contradict yung values na masosolve natin sa kinematic equation, whichever ang ating gamitin. So we will surely arrive with the same answer. So that's it for our lecture for today.